Vitamin C and E play that protective antioxidant role again, shielding the developing embryo during that very vulnerable stage.
And finally, the quality and survival of the larvae themselves.
Heavily influenced by what the mother provides. The study connects maternal transfer of high-quality protein and key fatty acids like DHA and EPA to heavier larvae, better yolk use, improved swim bladder inflation.
All critical for getting them through those first few days.
Absolutely. Crucial for survival and the transition to feeding.
A whole new era of communication in the global aquaculture industry is coming. Now you have the brightest minds in aquaculture right in your pocket. And what's best? You can listen to all of them while driving to a farm, traveling, or running errands. It's never been this good, and it's never been this simple. Welcome to the Aquaculture Podcast Show, the first AI-based podcast in aquaculture, where you'll find cutting-edge insights in everything that's working in aquaculture, nutrition, health, and production.
Okay, let's dive right into a really critical area for successful aquaculture, particularly for a species like Nile tilapia. We're talking broodstock nutrition.
Absolutely. It's the foundation, isn't it? Get that wrong, and everything downstream is compromised. Fecundity, egg quality, fry survival.
Yeah.
It all starts there.
Precisely. And what we want to do in this deep dive is pull out the most actionable insights from a key study focused specifically on optimizing tilapia broodstock diets for reproduction.
Right. Not just a broad overview, but really pinpointing those nutritional levers that the research shows make the tangible difference.
Our mission, then, is to understand what this study identifies as the most critical factors and their impacts on things like egg numbers, viability, and how well those larvae survive early on. Let's start with the big ones, the macronutrients. Protein and lipids. Protein first, we all know it's essential, often the most expensive component.
And the study gets quite specific on levels. They suggest a range. 30-40% crude protein.
But they emphasize pushing towards the higher end of that.
Exactly. They found that 35-40% protein really supports peak reproductive performance. We're talking higher fecundity, larger eggs, and even better protein content within the eggs themselves.
And it's not a one-size-fits-all number, is it?
No, definitely not. The study points out that protein needs vary. Sex matters, water quality, the type of system you're using, even how often you feed.
Interesting. Did they single out females?
They did. They noted that females particularly benefit when protein is above that 30% mark, better ovarian development, more frequent spawning, and higher larval viability. It really meets the specific physiological demands.
Okay. Now shifting to lipids. More than just energy, right?
Oh, much more. They're crucial carriers for essential fatty acids, which play vital roles in reproduction.
And the study highlighted a specific one.
Yes, linoleic acid. They found supplementing this, even at fairly low levels, 0.5 to 1.0% of the diet. It significantly boosted the telogenesis, that's yolk formation, and overall gonad development. And importantly, that translated to better egg hatchability.
So what's the recommended total lipid level?
The study suggests somewhere between 10 and 20% dietary lipid. But critically, it's not just the amount, it's the source.
Quality matters.
Absolutely. Getting those beneficial fatty acids from sources like, say, soybean oil or palm oil seem to support the best outcomes. The type of fat is key.
But there's a warning, too, about too much fat.
Yes, strong caution. Excess lipid leads to fat deposition, adipose accumulation, which the study observed actually compromises the quality of the gametes.
So it's a balance. You need enough of the right kinds, but overdoing it is detrimental.
Precisely. It's about optimization, not just maximization.
This focus on precision leads us nicely into amino acids. The study stresses just hitting a crude protein target isn't enough.
Definitely not. You have to consider the essential amino acids, the specific building blocks. If they're out of balance or deficient, they limit everything. Protein synthesis, hormone signaling, even gamete formation.
Which ones did the study call out as particularly important?
They mentioned several. Arginine, lysine, leucine, and methionine were highlighted for roles in hormone production, gonad development, and even immune support during that stressful reproductive period.
Any specific examples of impact?
Yeah, quite specific. Arginine, for example, at 19.2% of the dietary protein was shown to stimulate ovulation.
19.2% of protein.
And it was linked to nitric oxide synthesis, which affects reproductive processes and even influenced gene expression related to muscle development in the offspring. That's quite detailed.
Wow. And taurine.
Taurine at 1.0% inclusion showed benefits to improved fecundity, smaller size at first maturity, which impacts cycle times, and better larval development.
So targeted supplementation really can make a measured difference.
That's what the findings suggest, yes. Moving beyond just the crude numbers.
Okay, what about carbohydrates, often seen as the cheaper energy source?
And they can be. The study positions them as useful for sparing protein and lipids for their essential functions, especially if protein levels aren't at that super high end.
Is there an optimal range suggested?
They mention around 30-40% inclusion can work well in those contexts, meeting energy needs economically.
But there's a catch.
A significant one. The study cautions strongly against excess carbohydrates, particularly from sources that tilapia don't digest well.
What happens then?
It can lead to metabolic problems, and crucially, they found a direct link between those high levels of poorly utilized carbs and reduced reproductive efficiency.
So it's not just about cheap energy, it's about how the fish actually processes it and the impact on reproduction.
Exactly. Metabolic efficiency matters for reproductive output.
Right. Let's move to the micronutrients, vitamins, and minerals. The study says they modulate performance.
Yes, often working together, influencing hormone pathways and the immune system.
Which vitamins were key?
Vitamin C was mentioned in a range of 25 to 119 milligrams per kilo of diet, and vitamin E at 120 milligrams per kilo.
And their main role here?
Primarily antioxidative, protecting those delicate fats in the eggs and sperm, and maintaining the integrity of the gonads themselves, protecting against damage.
Makes sense. And minerals?
Several key ones. Selenium is vital for glutathione peroxidase activity, an enzyme that fights oxidative stress during gamete formation and embryo development.
Okay.
Calcium is essential for vitellogenin transport and binding into the developing egg. And zinc enhances gametogenesis and boosts immune defenses.
And again, the message is balance.
Absolutely critical. The study hammered this home. Too little or too much of these micronutrients can be really detrimental. We're talking potential reproductive failure or toxicity.
So just throwing in a vitamin mineral premix isn't necessarily the answer. The profile has to be right.
Precisely. Getting that balance correct is key.
This seems like a good point to talk about functional additives, the more advanced tools mentioned.
Right. These aren't primarily nutrients, but ingredients added for specific physiological benefits.
What kind of examples did the study give?
Things like probiotics, specific Bacillus subtilis strains were mentioned, and phytobiotics like spirulina.
And they showed benefits.
Significant ones, according to the study: improvements in egg size, fertilization rates, hatchability, and even larval survival.
Interesting. What about enzymes?
Functional enzymes like phytase and protease were also discussed. They help break down components in the feed, making nutrients more available and reducing the impact of anti-nutritional factors, basically getting more value out of the diet.
The study also touched on hormones.
Briefly, hormonal additives for maturation or strategies for monosex production, but with a very strong emphasis on the need for precise dosage. Get it wrong and you risk negative effects, deformities, stress.
Okay, so we've covered the key nutritional components. How does the study tie all this directly to the reproductive outcomes we measure in the hatchery?
It draws clear lines. For fecundity egg numbers, higher quality protein and lipids stimulate the hormone system, speeding up maturation, reducing time between spawns, and just increasing egg output.
Any specific examples there?
Yes, they cited diets enriched with N6 fatty acids, like from soybean oil, directly increasing spawning frequency and the total number of fry produced per female.
And fertilization success. How does nutrition play in?
Often through gamete quality. The study mentioned specific fatty acids like EPA and arachidonic acid, improving sperm motility and membrane integrity.
And the flip side, deficiency.
Protein deficiency, for instance, was linked to lower fertilization rates and more deformities in the larva. It shows that parental nutrition has a direct legacy.
Right. What about embryo development and getting those eggs to hatch?
Lipids, again, are key here. The right levels and types improve embryo membrane structure, support enzyme activity, help cells divide properly. This means fewer deformities, better hatch rate.
And the vitamins.
Vitamin C and E play that protective antioxidant role again, shielding the developing embryo during that very vulnerable stage.
And finally, the quality and survival of the larvae themselves.
Heavily influenced by what the mother provides. The study connects maternal transfer of high-quality protein and key fatty acids like DHA and EPA to heavier larvae, better yolk use, improved swim bladder inflation.
All critical for getting them through those first few days.
Absolutely. Crucial for survival and the transition to feeding. But there's a small caution here, too.
Yeah.
While essential, over-supplementing some things, like highly unsaturated fatty acids, could potentially increase oxidative stress if not balanced with enough antioxidants.
So that theme of balance persists right through to the larvae.
It really does. It's woven throughout the study's findings.
Okay, so if we boil it all down, what's the core message from this research?
I think it's crystal clear. Optimized, balanced broodstock nutrition isn't just helpful, it's fundamental. It dictates reproductive efficiency, hatchery output, and ultimately the viability of the whole operation for tilapia.
So mastering that mix, macronutrients, essential fatty acids, amino acids, the right vitamins and minerals, maybe some strategic additives, that's the foundation for success.
Exactly. Consistent egg production, high fertilization, strong larvae, resilient seed stock. It all traces back to getting that diet right.
And the study frames this not just as maximizing production now, but for long-term sustainability and resilience.
Yes, very much so. Refining these strategies is presented as key for building more robust and productive tilapia aquaculture systems.
Looking ahead, did the study suggest areas for future research?
It did. Things like investigating more local or novel feed ingredients, standardizing how functional feeds are used, understanding those complex nutrient hormone immune interactions better.
And technology.
Yes, leveraging real-time monitoring, tailoring diets even more precisely for different systems like RAS, and using digital tools for analytics and prediction. Lots of potential there.
Okay, that brings us to a final thought. Given all this complexity and the future directions pointed out, what area of broodstock nutrition do you think holds the most promise for the next big jump in tilapia hatchery performance?
That's a great question to ponder. Is it fine-tuning amino acid ratios, unlocking the potential of novel additives, or maybe getting much smarter with real-time data? Something for everyone listening to consider in their own context.
Definitely food for thought. How might these insights shape your approach? A good question to end on.
If you enjoyed this episode, make sure to follow the Aquaculture Podcast Show on your favorite platform. And don't forget to follow us on LinkedIn, Instagram, and Facebook to stay updated on the latest episodes and industry insights. Thanks for tuning in, and we'll catch you next time.